So this is the robot arm control circuit that I built. I'll turn it on. Okay, so initially we're in like state 0, which is the reset state or the idle state. As you can see, these are the LEDs that indicate the states with the most significant and least significant bits here. The state encoding is just like binary counting. So the first thing is in this state, we're going to test the outputs. So over here, it's the wrong place. Alright, so these are the address pins. It's 0 and 0 as we expect it to be. So then, what else? And read and write are both 1, as they should be, which is, in this case, these are active low pins, so that these are being inhibited. And also, step, as you can tell over here, this is the step input, or step output from the FSM, and it's also 0. And that has an LED, so it'll turn on when that is 1. And the only other thing is reset, which is pin 22, which connects to this white line here that goes to the counter, and that's also 0, which is good. That's what we want in the reset state. That means that it's being reset because it's active low as well. So then if we press the action button on this side, you see that it goes to the next state. And you'll notice, if you hold the action button, it continues on. But if you're in, this is the recording phase still, but if you press the reset button, you'll see that it goes back to 0, and we'll do the same thing in the playback phase as well. But anyways, the first state, we'll test the outputs again. So these are read is 5, is high, so it's being inhibited, but write is now 0, so it's actually active. And the address pins, let's see, it's 0, 0 as expected for the first state. And likewise, reset should now be 5, which is true, and step is still 0, as you can tell by the LED. Then you go to, so basically now we can move the motor around. You'll notice the phase and quadrature lights turning on. Green is the edge detection, and the other ones are just the synchronizers. So now if you press the action button again, it'll go to the next state, and in this state the address should be different. So let's see. It's now 1. So this is the least significant bit. So this is so it's actually 0, 1 is the address now. Good. Reset should still be high. That's good. And step is still low. And read is still high, write is still low. That confirms all of the outputs for that state. So then the next state, the idea is you would move the motor and then set the, then when you press the action button, it stores that into the position in memory. So now we're in this next state, and we'll look at the address again. It's now 1, 0, as it should be. Step is still 0. Write is still 0, as it should be, and read is still high. And reset is still high, so that's good. And then the next state, so this is the last read state, and we'll just look at the address again. It's now 1, 0, which is good. Oops. And then write is still 0, read is still high, reset is still high, as it should be, step is still low. Okay, so now When I press the action button again, what will happen is it'll transition into the playback state where something interesting should happen. Oh, this is disconnected, but it shouldn't be. This is just the direction, the direction pin for the motor. So anyways, I'll press this and we'll see what happens. Oh, so in this case we were actually very close to our target already. But I can move. So, okay, first thing, obviously it's not transitioning. I'm not sure why, and I'll explain more in the document about why I think this is the case. But what should be happening is it should be considered equal once it reaches the desired position, and then it should transition. But if I actually probe the pin, you'll see that oops. Yeah, you'll see it's not equal, I guess. But I think what's happening is it's sort of transitioning between being equal and being less than, and then it's kind of getting stuck. But if I remove this, you'll see that it moves and actually returns to that position once I put it back. So that indicates there is some kind of memory happening. And let's see. Yeah, see, it's like, it's sort of remembering a position. Now, I'll show that the other outputs are still good. So in this case, actually the right output is 5 now, which is good. That means it's active low. And the read is 0, which is good. It means that in this state, as we would expect, it would be reading from the register files. And step is also high now, so it's sending the pulses from this clock into the motor, which is driving it. Reset, still high, which is good. We don't want it to be resetting. Remember, that's active low. And the address should be 0, 0. That's 0. That's 0, indicating that it's getting the memory from the first position. So if my FSM was working properly, it would be transitioning to the next state once it reaches the position in memory. It's not doing this, and like I said, I'll get into why. But I believe that's everything that I wanted to show in this video. So this is the furthest extent that I have gotten the robot arm to work. And lastly, I'll just show that it resets from the playback as well. And there you go. So maybe I'll just move it around a little. There we go. See, it moved that way. Now it's going back. Yeah, see? It sort of remembers the position. Thanks for watching.